This is our first question. Find all the zeros of 3x cubed plus 10x square minus 9x minus 4 if one of its 0 is 1. So it is given that this is the polynomial and one of the 0 is 1. So if 1 is a 0 means x minus 1 is a factor of the given polynomial, right? X minus 1 is a factor means 1 is one of the 0. Or we can say p of 1 equal to 0. Same meaning. Anyways, x minus 1 is a factor. So we can divide this given polynomial 3x cubed plus 10x square minus 9x minus 4 by x minus 1. Okay, so here the first term here is 3x cubed and here it is x. So first we have to divide 3x cubed by x, that is 3x square. So we get here 3x square as the first term of the coefficient. Okay, now 3x square into x, that is 3x cubed here, then 3x square into minus 1 minus 3x square. Next step we have to subtract. So 3x cubed and 3x cubed will get cancelled. Now 10x square minus 3x square. See here minus minus coming together, so it is actually 10x square plus 3x square, that is 13x square. So here 13x square we got, and minus 9x. Don't have any like terms. We are writing the same here, minus 4 also. Now here the term, first term we have is 13x square and here we have x. So next we have to divide 13x square by x, that is we will get it as 13x. So we know the next term here, as in the quotient part, we need plus 13x. So 13x into x, 13x square, 13x minus 1 minus 13x. Okay, next step is subtraction. So 13x square will get cancelled. Now minus 9x minus 13x. See here also two negatives are coming together, so it is minus 9x plus 13x. That is, see here a positive number and a negative number is getting added and the bigger one is positive, so the answer is positive. Now 13 minus 10, that is 4. So 4x is the answer. So we know here we will get a 4x, then minus 4, as it don't have any like terms, we will have to write it as such. Now here the first term is 4x and here x, so 4x divided by x, that is 4. That is to be the next term in the quotient part. So 4 into x, 4x, then 4 into minus 1, minus 4. See, the remainder became 0. So x minus 1 is a factor, so we were expecting the remainder as 0, but we got this as another factor, 3x square plus 13x plus 4. 3x square plus 13x plus 4. So we can write the given polynomial as p of x equal to this into x minus 1. So already it is given that x minus 1 is a factor, so we can write it like this. Now we have to find all the zeros of the polynomial, means we have to factorize this. Okay, for the time's sake, let us take it as q of x. Okay, q of x, let it be 3x square plus 13x plus 4. Okay, splitting the middle term method, we will use that. Here the product of two numbers which we are searching for, 3 into 4. See, 3 into 4, that is to be the product. Okay, 3 into 4, 12, and this 13 as the sum. Sum should be 13 and product 12. So which are the numbers? 12 and 1, right? 12 into 1 we get it as 12 and 12 plus 1 we get it as 13. So we can split the middle term as 12x plus x. Okay, So here it is 3x square plus 12x plus x plus 4. Now in the first two terms, which is common, 3x square and 12x. So x is common there and 3 is also common there. So let us take 3x outside. When 3x is taken out, x is here. And from here, if we take 3 and x taken, then 4 is left. For the next two terms, it is already x plus 4. So here also we have an x plus 4. So we know it is to be the next common term. So we will put a 1 over here to make x plus 4 common. And when we take it out, we need a 1 here, no? So what happens is x plus 4 is common and the left terms 3x plus 1 is here. So we can write p of x as 3x plus 1 into x plus 4 into x minus 1. So in order to get the zeros of p of x, we have to give p of x equal to 0. That means 3x plus 1 into x plus 4 into x minus 1 equal to 0. This happens when x minus 1 equal to 0. X minus 1 equal to 0 means x equals 1. So this is one of the zeros that was already given in the question. Next, x plus 4 is equal to 0. It can also make p of x equal to 0. When x plus 4 equal to 0, x equal to minus 4. So minus 4 is another 0 of the polynomial. And if 3x plus 1 equal to 0, then also p of x will become 0. So here 3x equals minus 1. So x equals minus 1 by 3. So the zeros are 1, minus 4, minus 1 by 3. These are the zeros of the polynomial. This is our next question. Find the zeros of this polynomial. See, the speciality of this given polynomial is it includes roots. Okay, root 5 is there. So we cannot use trial and error method when it becomes 0 and all, it will be difficult. So let us choose splitting the middle term. Okay, so for that, the given polynomial, let us take it as p of x. P of x equals 5 root 5 x square plus 30x plus 8 root 5. Now, the product of two numbers which we are searching for is, see, the product of these two. Okay, so we need the product as 5 root 5 into 8 root 5. 5 into 8, 40. Root 5 into root 5 is 5. So 40 into 5, 200. Now 200 is the product of two numbers and the sum of those two numbers should be 30. So sum is 30 and product 200. So it is 20 and 10. When we add 20 and 10, we get 30, and when we multiply 20 and 10, we will get 200. So we can confirm these two are the numbers through which we have to split the middle term over here. So it will become 5 root 5 x square plus 20x plus 10x plus 8 root 5. Okay. Now for the first two terms, it is clear that 5 is common here and x is also common here. So we will take 5x outside. When 5 is taken out, root 5 is left here. And 1x is taken, so 1x is left here. And from 20 also we took 5, so 4 is left and x is taken out. Now, for the next two terms, for the next two, the common term or the common thing over here is 2. Okay, so first let us take 2 outside. What happens? Let us check. Then 2 is taken out here, 5x is left. And from here, if 2 is taken out, 4 root 5 is left. Now see, here we have root 5x plus 4 and here we have 5x plus 4 root 5. So in the next step, we don't have anything in common to take out, right? That is the situation now. So let us do an arrangement over here. See, 5x into root 5x plus 4 is there. And from the second bracket. See here, if we take root 5 outside, here our root 5 is there, and from here also root 5 we can take out, because 5 is actually root 5 into root 5. So in the next step, we are going to take a root 5 outside from here. So it is root 5x is left here. Root 5 is taken out, so root 5 is there, and x is also there. And from here also we have taken one root 5, so 4 is left. Now see, root 5x plus 4, root 5x plus 4. Now it is common. So in the next step, let us take that common thing out. So root 5x plus 4 taken out. Now 5x plus 2 root 5. This is the polynomial, given polynomial. Now we have to find the zeros, means we have to put p of x equal to 0. This happens when this is 0, root 5x plus 4 equal to 0, or 5x plus 2 root 5 equal to 0. These two are the possibilities to get p of x as 0. So here root 5 x equals minus 4, or x equals minus 4 by root 5, and from here 5x equals minus 2 root 5, so x equals minus 2 root 5 by 5, that is minus 2 by root 5. So these two are the zeros of the polynomial, minus 2 by root 5 and minus 4 by root 5. This is our next question. Find the zeros of 7y square minus 11y by 3 minus 2 by 3 and verify the relationship between the zeros and the coefficients. So this is the given polynomial p of y. Here the variable is y. So 7y square minus 11y by 3 minus 2 by 3. See here fractions are there, no, as the coefficients. So it will be difficult to handle these fractions. So in order to make it easy, let us take that 3 from the denominator part, it is taken out. So 1 by 3 is taken out. Now, here we don't have a 3 as the denominator part, right? We don't have a 3 over there. So suppose we need a 3 here, what we have to do? We have to multiply the numerator as well by 3. So it is actually 7 into 3, 21 y square is left here, right? 21 y square. Hope all of you understood. See, 3 was not here. If we need a 3 in the denominator, we have to multiply the numerator as well by 3. So it's 3 into 7, 21. 21y square is here. Then minus 11y minus 2. Okay, this is the next step. See here, we got a quadratic polynomial without any fractions. So now we will solve this. 21y square minus 11y minus 2. See here, what we need as the product is 21 into minus 2, right? 21 into minus 2, minus 42 we need as the product, and sum we need is minus 11. So we have to search for two numbers with sum negative 11 and product negative 42. Okay, so from where we will get this 42? Like that we have to think. From where we will get that 42? 1 into 42 is there, 2 into 21 is there, then no, 4 is not a factor. Here 3 into 14 is there. Okay, this one we have a hope, right? 3 and 14. Here product is negative and sum is negative. Listen, product is negative and sum is negative. That happens only when one number is negative and the other is positive, and the bigger one is negative. That is why the sum is negative. Okay, so this is the answer, or these are the numbers. 3, minus 14 and 3. Minus 14 plus 3, we will get it as minus 11, and minus 14 into 3, we will get it as minus 42. So let us divide, or let us spread the middle term with these two numbers. Okay, that we will write as the next step, 1 by 3 into 21y square minus 14y plus 3y minus 2. Now, from the first two terms, we have to take the common term. Okay, here 21y square and here 14y. So we know 7 is common there and y is also common there. So 7y is taken out from these two. So 7 taken out means 3 is left there. Y is taken from y square means y is there. Now here 7 is taken means 2 is there and y is already taken out. So it is like this. Now here we have a 3y minus 2 and here also we have a 3y minus 2. So when we take it out, we need a 1 also there. 1 is actually a silent part. Okay. So in the next step, we can write it as 1 by 3 into 3y minus 2 is common. Okay. So we can take it out 3y minus 2 into 7y plus 1. 7y plus 1. So this is the factorized form of the given polynomial. Now we have to find the zeros. To get the zeros, we have to put p of y equal to 0, and that happens when, 3y minus 2 equal to 0 or 7y plus 1 equal to 0. When 3y minus 2 equal to 0, 3y equals 2 or 3y equals 2 by 3. So this is 0 of the 1, 0 of the polynomial. And when 7y plus 1 equal to 0, then 7y equals minus 1 and y equal to minus 1 by 7. So these two are the zeros. So let us take alpha as 2 by 3, then beta as minus 1 by 7. Now, we have to check the relationship between the zeros and coefficients. Okay, so alpha plus beta and alpha beta, that is what we have to do. Alpha plus beta, see here 2 by 3 plus minus 1 by 7. Here the denominators are different, right? Adding two fractions and denominators are different. So we have to do cross multiplication. 2 into 7, 14 minus 3 into 1, 3 divided by 3 into 7, 21. So it is 11 by 21. And alpha beta is 2 by 3 into minus 1 by 7. So it is minus 1 into 2, that is minus 2, and denominator part 3 into 7, that is 21. Now we have to check whether this is same as minus b by a and c by a, right? So in the given polynomial, this was the given polynomial, right? So let us take down. Let us take it down. And we have to check whether minus b by a and c by a is also the same as alpha plus beta and alpha beta. Okay, now here minus b by a. Okay, minus b by a means this is b, right? This is a 7 and b is minus 11 by 3. Okay, this is b and this is c minus 2 by 3. So minus b by a means it is minus of 11 by minus of minus 11 by 3, right? B is negative here. So minus of minus 11 by 3 by a is 7. So negative and negative, two negatives coming together, it is positive. So 11 by 3 into 7, right? This 3 will come to the denominator part. 3 into 7, 21. So 11 by 21. See here also we got alpha plus beta as 11 by 21. So we can write alpha plus beta is same as minus b by a verified. Now, what is c by a here? C by a is minus 2 by 3 by 7. Here it is minus 2 by 21. And see here alpha beta was same, minus 2 by 21. So we can write alpha beta is equal to c by a is also verified. This is our next question. Obtain all the zeros of x raised to 4 plus 4x cubed minus 2x squared minus 20x minus 15 if two of its zeros are root 5 and minus root 5. See, zeros are given as root 5 and minus root 5. If root 5 is one of the zero, then we can write x minus root 5 is a factor, right? And if minus root 5 is a 0 means we can write x plus root 5 is the factor. So we got two factors of this given polynomial, x minus root 5 and x plus root 5. So we can write x minus root 5 into x plus root 5 is also a factor, right? Okay, so this into this. is also a factor. Now it is of the form a plus b into a minus b, right? A plus b into a minus b, a square minus b square. So x square, see, in place of a we have x, and b square in place of b we have root 5. So root 5 square, root 5, the whole square is actually 5. So we can write x square minus 5 is a factor of this given polynomial. Now we can divide x raised to 4 plus 4x cube minus 2x square minus 20x minus 15 by x square minus 5. So we'll get a quotient and we will again factorize that. Okay. Now here we have x raised to 4 and here we have x square. When we divide, we will get x square. So x raised to 4 by x square. Hope all of you understood. X raised to 4 by x square is x square. That is what we have to write it here. Okay. Now, say x square into x square, x raised to 4, x square into minus 5, minus 5x square. See why we have written it over here. Here we have x cube, but we are not getting an x cube term when we multiply this quotient part by the divisor. So x square into x square is x raised to 4 here, and x square into minus 5 minus 5x square. Okay, like terms together. Now we have to subtract. So x raised to 4 get cancelled and 4x cube will come here. Now minus 2 minus minus 5, right? Minus 2 minus minus 5. See, two negatives coming together, so it is positive. So minus 2 plus 5, that is, we have to subtract 2 from 5. So it is 3. So it is plus 3x square. Now other two terms don't have any like terms, so we can write it down as it. Here, see here the first term is 4x square and here x square. So 4x square divided by x square. What we get? 4, right? So plus 4 here. 4 into x square, 4x square, 4 into minus 5, minus 20, right? 4 into minus 5, minus 20. See, here also we have to write it under the like term, like this. Okay. Now, see here it was 4x cube and we got x square term, right? Okay, so x square term should come here like this. See here it was 4x cube. No, by mistake we wrote it as, sorry, I wrote it as 4x square. Now it is 4x cube. 4x cube divided by x square. 4x cube divided by x square. We will get it as 4x. So we have to write 4x over here. Okay, so 4x into x square. 4x into x square is 4x cube. Next 4x into minus 5 minus 20x. See, like terms together. Now 4x cube got cancelled. 3x square don't have any like term. 20x also subtraction got cancelled. Now we have 3x square minus 15. 3x square is the first term here, and here it is x square. When we divide 3x square by x square, we get it as 3. So plus 3 is the next term. So 3 into x square is 3x square minus, see here we have a negative sign, and 3 into 5, that is 15. Okay, now the remainder is 0. Okay, we were expecting the remainder as 0. This next factor is x square plus 4x plus 3. So we can write it as x square minus 5 into x square plus 4x plus 3. X square plus 4x plus 3. This is actually the given polynomial. So we have to find all the zeros, right? Now we have to again factorize this, right? Here, this is of the form x square plus a plus b into x plus ab, right? X square plus a plus b into x plus AB. This is the identity which we can use over here because the last term is not a perfect square and the first term is a perfect square. In such cases, we can use this identity, and this is actually x plus a into x plus b. Okay, in place of x square, we have x square itself, right? So we can understand that x, in place of x, we have x. And in place of a plus b, we have 4, right? And in place of AB, we have 3. So we need the sum as 4 and the product of two numbers as 3. So obviously it is 3 and 1. So 3 plus 1, we will get 4, and 3 into 1, we will get that as 3. So we can write it as x. In place of A, we can give it 3. Then in place of B, we can give it as 1. So x plus 3, x plus 1. Okay, so it is x square minus 5 into C. In place of A, if we give it as 3, then B will become 1. So it is x plus 3 into x plus 1. Now, see the first part, this factor is already considered and the two corresponding zeros is already given in the question. The other zeros of the polynomial we have to take from the next part. See, x plus 3 is equal to 0 means x equals minus 3. X plus 1 equal to 0 means x equals minus 1. So minus 1 and minus 3. Then from here, it was already given in the question, plus or minus root 5. Okay, it was there in the question are the zeros of the given polynomial. This is our last question of this video. Find all the zeros of this given polynomial if two of its zeros are 2 plus root 3 and 2 minus root 3. This is almost similar to the last question. See, 2 plus root 3 and 2 minus root 3 are two zeros. Means what we can say? We can write x minus 2 plus root 3 and x minus 2 minus root 3 are factors of this given polynomial, right? 2 plus root 3 is a 0, means x minus 2 plus root 3 is a factor. 2 minus root 3 is a 0, means x minus 2 minus root 3 is a factor. Now we can multiply these two and we can say the product of these two will also be a factor, right? Now let us open the bracket inside. See, minus, let us take this negative inside. So it will become x minus 2 minus root 3 into here. This negative is taken inside. So x minus 2 plus root 3. Now in the next step, we have to multiply each and every term, taking it into the bracket. X into x, x square, x into minus 2, minus 2x, x into root 3, positive root 3x. Now minus 2 is taken out inside. Minus 2 into x, minus 2x, minus 2 into minus 2 plus 4, minus 2 into root 3, minus 2 root 3. Next, root 3 we have to take in. Minus root 3 into x, that is minus root 3x, minus root 3 into minus 2, positive 2 root 3, minus root 3 into positive root 3, that is minus 3. So here we have only one x square term. Let us take it here. Next, minus 2x is here. Okay, and again minus 2x is here. Then minus root 3x is also here. See, minus root 3x and plus root 3x will get cancelled. And only two x terms, right? Only two x terms, minus 2x, minus 2x, minus 2, minus 2. Actually, it is same as minus 2 plus minus 2, right? That is, it is minus 4. So we can combine this minus 2x and minus 2x and we can write it as minus 4x. Okay, x terms is done. Now see, minus 2 root 3 and plus 2 root 3. We can cut it. Now 4 minus 3. 4 minus 3, 1. Okay, now we can write this as the factor of the given polynomial. Right, the given polynomial was p of x is equal to 2x raised to 4 minus 9x cube plus 5x square plus 3x minus 1. And now x square minus 4x plus 1. See this one, x square minus 4x plus 1 is a factor of p of x. Now, as we have done in the previous question, now we have to divide, right? We have to divide 2x raised to 4 minus 9x cube plus 5x square plus 3x minus 1 by x square minus 4x plus 1. Okay. So here we have 2x raised to 4 and here we have x square, 2x raised to 4 divided by x square, x raised to 4. When we divide, we get as x square, right? So it is 2x square here, 2x square into x square, that is 2x raised to 4. Now 2x square into minus 4x, that is minus 8x cube. 2x square into 1, that is plus 2x square. Next we have to subtract. So like terms, 2x raised to 4, 2x raised to 4 will get cancelled. Here we have minus 9 minus minus 8. Minus 9 minus minus 8. So it is minus 9 plus 8, that is minus 1. So it is minus x cube. 5x square minus 2x square, that is positive 3x square plus 3x minus 1. Here minus x cube and here x square. When we divide, we get it as minus x, right? Minus x cube divided by x square. So minus x into x square, that is minus x cube, minus x into minus 4x, that is plus 4x square. Now minus x into 1 minus x. Okay, again we have to do subtraction. So minus x cube will get cancelled. 3x square minus 4x square, that is minus x square. 3x minus minus x. See 3x minus minus x. It is same as minus minus together plus 3x plus x, 4x minus 1. Now here we have a minus x square and here we have an x square. So the next term is minus 1, right? Minus 1 into x square. When we divide minus x square by x square, we get as minus 1. So minus 1 into x square is minus x square. Then minus 1 into minus 4x. So it is plus 4x minus 1 into 1, that is minus 1. See, all the terms are alike, so it is 0. Remainder is 0. So we can write 2x minus x minus 1. That is the next. We have to find out the zeros, right? So we can write this as another factor. Now let us take this quotient term as q of x over here, and next we have to factorize it, right? Here, actually we need the product of two numbers as minus 2, right? The product of two numbers, 2 into minus 1, minus 2 we need, and the sum we need it as minus 1, right? Here the coefficient is negative 1. So sum is negative 1 and product is negative 2. Product is negative means one is positive and the other is negative, and the bigger one is negative. So minus 2 and 1. See, when we multiply these two, we will get the product as minus 2, and when we add these two, we will get the sum as minus 1. So we can split the middle term over here with these two numbers. So 2x square minus 2x plus x minus 1. So from the first two terms, let us take 2x as common. So 2x is taken out. Now here x minus 1 is there. And from the next two, we can take x minus 1 as common. And here, when we we know that x minus 1 is to be taken out in the next step. So we have to put a 1 over here. So x minus 1 is taken out. Here, when x minus 1 is taken out, 2x is left. And here, x minus 1 is taken out, so plus 1 is left. So this is the factorized form of that quotient. So we can write the zeros from here, right? X minus 1 is equal to 0 means x minus 1 equal to 0 means x equal to 1 is a 0 of the polynomial. Next, 2x plus 1 equal to 0 means 2x equals minus 1 or x equals minus 1 by 2 is a 0. So 1 minus 1 by 2 are zeros of the polynomial. Again, two other zeros are already given in the polynomial. See these two. So 2 plus root 3 and 2 minus root 3 are zeros. It is already given. So these four are the zeros of the given polynomial. Okay, so we can conclude like this. These four are the zeros of the given polynomial. Okay, hope all of you understood. Thank you.